like we said, we need to have a function of, we need to express this in the form, for a geometric series, we know the representation, it has to be in the form n is equal to 0, then infinity there, and we should have a r to the power n. So this will always be equal to a over 1 minus r. So now we need to represent this function that we have in this form, but if we look at this function, it's not entirely possible to express it direct into this form. So what do? We need to split this into two simpler functions by the knowledge of partial fractions. Okay, so we have this function f of x is equal to 4x over x squared plus 2x then minus 3. So now we need to transform this into, we need to change it into simpler functions by the use of the knowledge of partial fractions. So we are going to have 4x here. Okay, we are going to have 4x here divided by x squared plus 2x then minus 3. So now this will be equal to, if we look at the function that we have down here, we see that it's a function that we can factorize. Okay, it's a function that we can factorize, and it's going to be, so if we get this function which is x squared plus 2x minus 3, so we can factorize this function. So we are going to have the product will be negative 3 and the sum is negative 2. So what two numbers can we multiply that will give us negative 3, and then when we add them they should give us 2, positive 2. So we know that those numbers will be negative 1 and positive 3. Okay, so we are going to have x squared plus 3x then minus x and then minus 3 this side, so that when you factorize here we're going to have x open bracket x plus 3, even this side we're going to have x plus 3, then here we have a negative 1. So this will turn out to be, okay, this would turn out to be like this. So this would turn out to be x, this would turn out to be x, we'll have x minus 1 here and x plus 3. So this is what we have on the denominator. So right in our function is going to be 4x over x minus 1 multiplied by x plus 3. Okay, sorry for that. So we proceed. So this is our f of x, the function that we have. Okay, so this is our f of x. So now by partial fractions, okay, so I think let's go to the next screen so that we start the partial fraction decomposition. Okay, so by the knowledge of partial fraction decomposition, we know that we are going to have 4x this side, so we have 4x divided by divided by x minus 1 multiplied by x plus 3. Okay, so this is like this. So this would be equal to a over x minus 1 then plus b over x plus 3. Okay, x plus 3 there. So what we do is I use this method of multiplying everything by what we have in the denominator there, which is x minus 1 and x plus 3 there. Okay, so when we multiply that by what we have this side, we multiply this whole part here by this side, we are going to have 4x there. The denominator will cancel with that and we will just remain with 4x this side. Then this will be equal to, just remain with 4x that side, then this side will remain with so when we multiply this whole thing here, multiply it by this part, we are going to have a multiplied by x plus 3. The x minus 1 will cancel with the x minus 1 there. Then when we go to b plus b here, the x minus 3, when we're taking this whole thing, multiplying with this part, x minus 3 will cancel with that, then we remain with x minus 1. Okay, so this is what we have. So expanding this side, so this side will remain with 4x, then this side we are going to have a x plus 3a plus bx minus b here. So this side we can see that the terms that we have that contain the x variable, we have this term here. So we have this term here, the ax term and the bx term, and then the constant variables, we have this term here and the negative b. So we can see that 4 will be equal to a plus b, because these are the values that have the x variable. So the 4 will be equal to that, and so this will be our first equation. This will be our equation 1. Okay, so we proceed. So this will be our equation 1. Then we are going to have, we can see this side that we don't have any constant term on the left that doesn't have the x or anything attached to it. So that means that our constant variables on the right should be equal to 0, because on the left we don't have any constant variables. So we are going to have 0 is equal to 3a minus b. So this would be our equation 2 here. Okay, right. So from the second equation we can see that b, we can see from the second equation that b is equal to 3a. So if we solve the second equation, the first equation, and then we replace with what we have from the second equation, we are going to have 4 is equal to, so where there is b, we will replace with 3a. So we have a there, then where there is b, we will replace with 3a. So we are going to have 4 this side is equal to 4a, and this will imply that our a is equal to 1. Okay, positive 1 there. That would be our A value. Then B would be equal to, when we use this equation there, we'll find that B is equal to positive 3. So now we've decomposed our given function into partial fractions, simpler fractions. Okay, so let's proceed. So we know that our A is equal to 1, and then our B is equal to 3. Okay, so let's proceed. We are going to take our values to the next page. So our function is this one we are interested in. So we want to get this. Okay, this part here. So we've identified that our A value, we've identified that our A is equal to positive 1, and then our B is equal to 3, right? Let's check that. Okay, right. So we are going to express our f of x. Our f of x will be equal to, so A is 1, we're going to have 1 over x minus 1, then plus our B value is 3, so this will be 3 over x plus 3. So we have these two functions that we are now going to convert into our geometric power series. Okay, so we are going to do it individually because we've decomposed our function, so we will do them separately. We will first begin with 1, which is here, then we come to this one here, then we'll combine our final result. Okay, so for the first one, let's call this f1 of x. So this one, call it f1 of x. So our f1 of x will be equal to 1 over x minus 1 there. So we need to convert this to the geometric power series of this kind. Okay, so we have infinite there, then we have n is equal to 0, a r to the power n, which should be equal to a over 1 minus r. So we need to convert this function here into this form. Okay, so how do we do that? We want to have a 1 here where there is x, and then we want to have x there where there is 1. Okay, so if we were to interchange this, we are going to have our f1 of x will be equal to 1 over, we take the negative 1 this side, okay, then plus x here. So we haven't changed anything to the function. So now we want to have a negative where there is a positive value here, where there is a positive sign. So we are going to have 1 over, we have a negative 1 here, then a negative, two negatives, we know that will give us a positive value, so we'll put a negative there, then negative inside of x. Right, so now we still have this negative 1 this side, we still have this negative 1 which we don't need. We need to have a positive 1 at that point. Okay, we need to have a positive 1 at that point there. Okay, we need to have a positive 1 here. Sorry, it should be in the next one. It's stuck. Okay, so we need to have a positive 1 at this point. not a negative 1. So how do we achieve that? We can write this in this form. So we're going to have our f1 of x be equal to, we have a 1 there. So to change this negative, we know that we need to multiply both sides by what? By a negative. Okay, we need to multiply both sides, which is the numerator and the denominator, by a negative 1. So we are going to have a negative 1 on top here, then divided by, that will be a positive 1, and then we have a negative value there. Okay, so this negative is more like we have 3 negatives that we are multiplying. We know that the negative here, these 2 negatives, okay, let me use a different color to highlight that. Okay, so we know that these 2 negative values, okay, these 2 negative values here will yield a positive value. So if we multiply with a negative value, we're going to have a negative. It's more like we're multiplying 3 negatives. So we have a negative here, then we have positive x here, which is 1 minus x. So from here we can see that we've expressed our given function here, this function from here to this point there. Okay, so we can identify that our a value is equal to negative 1, and then our r will be equal to x. Okay, so we can now write our geometric power series for the f1 function. Right, so let's get that. Okay, let's get that. We're going to have our geometric power series for the first function that we chose. Okay, so let's just move this on top. So we need to write this in this form. Why the color is not changing here? Okay, so we need to write this in this form. N is equal to 0, then we have infinity there, then we need to have a r to the power n. So we've identified our a value and our r. So n is equal to 0 there. So we have a, which is negative 1. So we have a negative 1 there. Okay, then we have r, which is x to the power what? N, to the power n there. So this is our geometric power series for the first function. Okay, so now let's proceed with the second one, then we'll combine the final result. So we had our second function, which we'll call f2. Okay, so we'll call that our f2 of x. This will be equal to, we had the 3 here over, that was x plus 3. Alright, so let's just check that out and confirm. Okay, it was pretty much like that. So we need to convert this again into the same usual form, which is a over 1 minus r. Okay, because this is centered at 0, of Of course, we should remember that fact. So now let's just move this a bit down here. Okay, so we have our given function there, which is f2 of x being equal to, we had the 3 over x plus 3. Okay, so that's what we have as our function. So we need to express it in the form a over 1 minus r. So how can we do that? All we need is to rewrite this function. So we are going to have it in this form. It's the same as 3 over 3 there, then plus x. So now we need to change the negative there, and we need to change the 1. So we can also write this as 3 over 3 there minus negative x. Okay, so then we can multiply the numerator with 1 over 3 and the denominator also with 1 over 3. So if we do that, our f2 of x will then be equal to, we'll have okay, so we'll have a 1 on top there, a 1, then divided by, we'll also have a 1 there, then minus, we'll have a negative 1 over 3 there, and x. Okay, so we can see from here that our a value is equal to 1, and then our r will be equal to negative 1 over 3 of x. Okay, negative 1 over 3 of x. So this will be our r value. Okay, that will be our r value there. This will be our r value, and this is our a value. We can then write our geometric power series. Since we found all that we need, we can write our geometric power series representation of the function. So we know that it's supposed to be in the form of infinity here, n is equal to 0, and you have a there, r to the power n. So our a is 1, so this is equal to infinity, n is equal to 0. Our a is 1, which we can show or not show, it's still okay. And then our r is negative 1 over 3 of x, then to the power n. So we can simplify this, and we are going to get this. So we can factorize the negative 1 there and a 3. So we are going to have negative 1 over 3, this to the power n, then multiplied by x to the power n. Okay, so this is our geometric power series representation of the second function. So before we combine the results, remember that we had two functions that we separated, okay, by partial decomposition. So before we combine the results, we need to find the radius of convergence and our interval of convergence for both. Then we'll combine